So, want to take a moment to talk about this last one. This one, the logic works. It takes a minute to understand. So let's break it down one piece at a time. All right. So 3/4 is 3 times 1/4. All right. 3/1 times 1/4 equals 3/4. So that's what they're talking about right there. All right. So 5 times 3/4 is the same thing as 5 times 3 times 1/4. All right. So 5 times 3 times 1/4, they're kind of missing the multiplication symbol in there. All right. Because what you would do then is go 5 times 3, which is 15, and then 15 times 1/4. Turn 15 into the fraction, top times top. You get 15/4. All right. So that one is breaking apart numbers, but that one's kind of advanced. So if that one makes sense to you, awesome. If it doesn't yet, don't worry about it. There's 3 other ways on this page that you can use, plus the algorithm that we already used. So there's actually 5 ways that we've gone over to get the answer on this one, which is pretty cool. All right, moving on. Just a couple of problems where I just want you to think it out real quick, and then we're gonna move on. You don't even have to solve them. So, what would you adjust the diagram to represent 4 times 2/5? What is the shaded value? The shaded value. What is the value of the shaded parts of your diagram? All right. So, how could you represent this model to do this problem? How many different times would you have to see that model? And then think about how many fifths that would give you. And for now, I just want you to figure out by thinking about the pictures. And if you have to draw the pictures on your desk. But how many fifths would you get if you had 4 groups of 2/5? All right. And then let's actually, I think they were supposed to change this. So don't worry about that. All right. And then I think we have one more page. If I can get there. There we go. Too many clicks. Okay. The last thing is May said one more word problem. May said that to multiply any fraction by a whole number, she would multiply the whole number and the numerator of the fraction and keep the same denominator. Do you agree with May? Explain your reasoning. All right. So I want you to think about if this would work. May said that to multiply any fraction by a whole number, she would multiply the whole number and the numerator of the fraction and keep the denominator, or keep the same denominator. Is that what we've been doing? Do you agree with May? Talk to your tables about it. Oops. All right. So yeah, that's exactly what happens, right? May said to multiply any fraction by a whole number, she would multiply the whole number and the numerator. So let's say 5 times 1/2, right? She said that she would multiply the numerator, or the whole number and the numerator. So 5 times 1 equals 5. And then she would keep the same denominator. And if you think about it, if we're turning a whole number into a fraction, we only use the 1 to turn it into a fraction. So is it kind of like keeping the same denominator? It really is. So May's correct. She's not doing what we're doing, but she knows math well enough to know that that's going to work. Anytime you're multiplying a whole number times a fraction. Now, if it's a fraction times a fraction, that's not going to work. But a whole number times a fraction, that's a cool trick. All right, and then we can multiply 4. Why can we multiply 4 times 2 to get the numerator of the product? All right, so I just want you to look at this picture real quick. Why can we multiply 4 times 2 to get the numerator of the product? And you've already done this problem, so you already know. So just review. Okay, we can do 4 times 2 because what we're looking at is we're looking at 2/3 4 times, right? And according to May in our previous problem, all we have to do is multiply the numerator times the whole number, 2 times 4 equals 8, and then keep the denominator the same, which would be the same as if we put the 1 in the denominator position. So it is 8/3. All right, so there is some practice, and we're gonna keep on moving forward and even add some division into our fraction stuff. So I'll see you then. Bye.